2, 3.
What's up, team? Today we're going to talk about how to show that some quadrilateral is definitely a parallelogram. So before I gave you a parallelogram, you learned about some of the properties of it, you had some given information, your task was to find some sort of missing information. Here we're going to flip it around entirely. I'm going to give you some sort of quadrilateral. You'll be given some sort of quadrilateral with some given information, and your task is to use that information and determine what type of quadrilateral it is. This video is going to show you how to find out if it's definitely a parallelogram. So there are 5 conditions in which you can show just one of the 5 are true, then you definitely have a parallelogram. Again, you don't need to show all of these things, you need to show one of these things. And I'll walk through this here. So first one, if you can show that both pairs of opposite sides are parallel, then you definitely have a parallelogram. I mean, that one should be a given, that's the definition of a parallelogram. So if you can show that the top and bottom sides are definitely parallel, as well as, in this case, the left and the right sides are definitely parallel, then you have a parallelogram. Condition number 2, both pairs of opposite sides are congruent. If you can demonstrate that the opposite sides are congruent and the other pair of opposite sides are congruent, then you definitely have a parallelogram. You don't need to do any more. This is enough to say, yes, that's definitely a parallelogram, and all of the properties of parallelograms will hold. All right, the third one. Oh gosh, not a great drawing, doesn't look like a parallelogram, but if we can show that one pair of opposite sides are both congruent and parallel, then we definitely have a parallelogram. So I'll go top and bottom here. If we can show that these two sides have the same length and that they're parallel to one another, then we definitely have a parallelogram. Fourth one, both pairs of opposite angles are congruent. So if we can show that these two angles are congruent, as well as the other pair of opposite angles are congruent, then we definitely have a parallelogram. All right, the fifth and final condition, again, you only need to show one of these things. This is the fifth option for you. If you can show that both diagonals bisect each other, then you definitely have a parallelogram. It's the first time we're going to interact with diagonals in this particular lesson. Just having diagonals is not enough information. This says that where they meet is exactly where they chop each other in half, meaning this line segment and this one must be congruent, as well as these two line segments. If you can demonstrate that to be true, you don't even have to say anything about the sides of the parallelogram. If this is true, that's enough to say you have a parallelogram, and it's enough to say that all the other stuff is true as well. So you only need to show one of these things for all of them to be true. Okay, hang on, we're going to run through an example here next. Okay, here's the example we're going to work with. It's a little bit of a doozy. It looks kind of complicated, but we're going to work through it. So we have some given information. We have a proof statement. Now, we're not going to do a formal two-column proof. I'm not interested in that. We're just going to kind of work through the picture, and we're going to show that this information is true based on the given information with kind of symbols, and we're going to talk through it. When you're turning things in, I am going to need to see words on your paper. There's some examples attached here on Classroom. So let's dive in. Let's figure out what we know. Let's mark this thing up and determine if we definitely have a parallelogram going on. So first, triangle ABC is congruent to triangle FED. So ABC is congruent to FED. Okay, well, we know that if two triangles are congruent, then corresponding parts of congruent triangles are also congruent. That's CPCTC. So that means that this side is congruent to this side. So AC is congruent to DF. And we can see that in the statement. AC are the first and third letters. FD are the first and third letters in the statement. So those are definitely congruent. Similarly, there's a bunch of other stuff that's going to be congruent to one another. But I'm not as interested in that because I peeked ahead. I looked at the proof statement. Our task at hand here is to show that ACDF is a parallelogram. That's our goal. It looks like a parallelogram, but we need to show that it definitely is based on those 5 conditions, or one of those 5 conditions that we looked at a minute ago. So far we have opposite sides that are congruent. That's a really good start, but it's not enough information yet. So let's look at the rest of the given information we have. We have that CD is congruent to CG. CD is congruent to CG. So CD is congruent to CG. Okay, well that really only seems to serve this triangle over here. It looks like an isosceles triangle. That's nice, but that doesn't really help us show that this is a parallelogram. So we'll put that information on hold for just a second. The last piece of given information is we know that CG is congruent to AF. Oh, that's interesting, because we know that CG is also congruent to CD. So the transitive property would say that CD and AF are congruent to one another. Let's see if that helps us. So CD and AF, nice, that's good news. Those are congruent to one another. So now we have this parallelogram, and we have two pairs of opposite sides that are congruent to one another. That is one of the conditions we just discussed. So at this point in time, I'm going to put my pen down because we are done. We have demonstrated that this is definitely a parallelogram because two pairs of opposite sides are congruent. We don't have to satisfy all 5 conditions. We need to satisfy one of the conditions, and then the rest of it is also true because there's no alternative. There's no counterexample to a quadrilateral where opposite sides are congruent where the rest of those conditions aren't also met. Okay, let's play around with this. This is tricky. This is a little bit different than stuff we've done before. I don't have a step-by-step directions for this type of thing. You need to look at the information you're given, look at the conditions that would work, see which ones might fit your situation, try to demonstrate it. If it doesn't work, either try again or try one of the other conditions. So this kind of stuff takes time. It's not a step-by-step type of thing. You might approach it different than me. You might approach it different than your BFF, and you could still both be correct. Okay, go ahead and dive into your practice problems. Let me know if you have questions. You got this.